This will be about the surface area of polyhedra. The surface area of any polyhedron is the sum of the areas of the faces, the polygons that are the faces. Probably the most straightforward way to do this is whenever this is a pentagonal prism, whenever you have a polyhedron, if you can just unwrap it like a present and see all the pieces. This is
Myra, please come by the main office. Myra, come by the main office.
So here we have an unwrapped pentagonal prism. It's a pentagonal prism, all the pieces of it. You notice that once it's laid out, we have two pentagons. You can find the area of those like by using the apothem or whatever method that is available to you. This one happens, and there will, since it's a prism, there will be 5 rectangles. These happen to be squares. And this particular one, since it's regular, they're all the same. So you would do 1 and multiply by 5. When we lay it out like this, we call it a net. Here are the nets for some other polyhedron and other shapes. So a 2-dimensional representation of the surface area of a solid is called a net. Here's some more information on that. Here's a box, a rectangular prism that's laid out. You see it opening. You can do the individual rectangles to find it. Here is, and some terminology here. The 2 upper and lower are called bases. The rectangles connecting the prism are called lateral faces, and then there are lateral edges. We talked about this last time as well. Remember, the lateral faces are the ones that are on the side, lateral being a word for side. Another way to think of it is as a label. So here are some more nets. Figure out what each one is. Maybe pause. This is a cylinder. This is a triangular prism. This is a hexagonal prism. Take a look at this and figure out which one is the correct one once the triangular prism is folded up. It's this one. A few definitions. A prism is a polyhedron with 2 congruent and parallel faces, which are called the bases. The other faces are called lateral faces. So you find the one, they're all going to be correct. The lateral faces are always rectangles in a prism. So you find the ones that's not a rectangle, and those must be the bases. Here it's the triangles, here it's the pentagons, and here they're all rectangles, so it doesn't matter which one you choose to be the bases, just 2 that are opposite, parallel, and congruent, which they will be since it's a rectangular prism. Any 2 is fine on a rectangular prism. A cylinder. A cylinder is a solid with congruent and parallel circular bases. We'll deal with it as circles, the top and the bottom, dealing with the radius or the diameter, and we'll talk about the height as the perpendicular distance between the 2 rectangular bases. In each of these shapes, they might be straight or they might be crooked. We have a better name for it than crooked, of course. In each of the shapes, we'll talk about the axis as being the line segment passing through the center of the bases. So in this case, through the center of the bases, through the middle to the middle of the pentagon, the center to the center of the triangle, or from whichever rectangles that you choose. If the axis, and if it happens to be a cone or a pyramid, then it'll be from the vertex, the line segment going from the vertex perpendicular to the base, or to the center of the base, excuse me, from the vertex to the center of the base. If the axis is perpendicular to the base, then we call it a right solid, like a right angle. If it's not perpendicular, then we call it oblique. A little bit.
Here, please report to the circle drive. Kaiser to the circle drive.
A little bit of conceptual notion about how we're going to do surface area. Here's a T10, some Harney & Sons vanilla. I can take and wrap around the outside very much like a label. To wrap my tin, surface area is like wrapping a present. Then I'll need a square to go on the top, and I'll need another square to go on the bottom. So if I unwrap this and form a net, this is what I'll have. I'll have a lateral surface area and the top and the bottom, which are the squares, which are the bases. Okay, well, lateral, some people might have trouble remembering. If this were a label on the tin, then you could remember it. And you're used to unwrapping things, taking labels off of jars and stuff. If you take the label off of here, you see that it's a rectangle. A few things about it. The height, it makes a rectangle. You have length and width. Notice that the width of the rectangle is the same as the height of the prism. What about the length of the rectangle? Well, let's talk about it in terms of the prism. If I wrap it around, having wrap it around, notice that the label, or the rectangle, is the same as the perimeter of the original tin, the rectangular prism. So we can say that the length of the rectangle is the same as the perimeter of the label, the lateral surface area. So then the length would be the perimeter of the base, and then to cover it fully we would need the area of each of the bases. The same principle works for a cylinder. Here we've got some ice cream, southern pecan, yum, 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 yum. It had a label on it. The label would go around like this. As you're familiar with labels, when they open up, take them off, they make a rectangle. Well, and then of course the top and the bottom. So this would be a net for a cylinder. Again, it's a rectangle. Just like with the prism, the height of the cylinder is the same as the width of the rectangle. What about the length, though? The length of the rectangle, we wrap it around, and we see what we call it when it's on here. Well, when it's on here, it's a circle. And the paper, the label, is the circumference of the circle. We wrap it around. It's the distance around the circle. It's the circumference of the cylinder. So when we lay it out, take the label off and lay it out as a rectangle, we see that the circumference of the cylinder is the same as the length of the rectangle. And again, the width of the rectangle was the height of the cylinder. And we have the lid and the bottom to complete it. That's in a picture here where you can see it. The terminology that we use on a cylinder are, of course, the bases, the radius of the base, and the height being the perpendicular distance between the two circular bases. This is mentioning here that 2 pi r is the length of the rectangle. That's the label. Again, label, lateral, lateral, label. That might help you remember. Lateral area is the area of the label when you unwrap it. When you wrapped it around the circle, it was the circumference. So it's 2 pi r, which of course is the circumference of a circle. The height of the original cylinder is the same as the width of the label or the lateral area. We have some formula for that, and here they are. Okay. The surface area of a right prism and the surface area of a cylinder. These do not work for ones that are not right. So that's a caveat of beware. Here are the letters that are used. B is the area of the base, the yellow in each one of these. So again, in many of these formulas, the use of a capital letter indicates something that was calculated. The use of a lowercase letter indicates generally a measurement. Here, the height. Capital B is the area of the base in either one of these, so you calculate the area. P or C is the distance around the base. Now remember, rectangle people talk about length and width and perimeter, but circle types of people talk about pi and radius and diameter and circumference. Either way, P and C, it's the distance around the base. S is the surface area of the solid. That's the whole thing that you're looking for, what it takes to cover your item. And H is the perpendicular height of the solid. Look, these are the same. It just has a P instead of a C. Both of them mean the distance around the base. They're the same formula. This uses the rectangle language and this uses the circle language. I will admit to you, however, that you're not going to see this used very often. At least I don't see it used very often. I'm telling it to you because it's the way it is on the 8th grade STAR test, which you're going to have to take, so you won't be surprised about it. But also notice that this is 2 times the base. Pi r squared is the area of the circle, that's the base. 1 for above, 1 for below, that's 2 pi r squared. 2 pi r is the circumference of the base. Circumference is 2 pi r times the height. So that's the label. That's the rectangle, that's the label, the lateral surface area. And this is just written with a little distributive property to make it a little bit easier to calculate. So that's our 2 formulas, one for the surface area of a right prism, the other for the surface area of a right cylinder. Remember, it does not work if it's not right. Here endeth the lesson.